Hello, my name is Yang Li. I'm your AP teacher. And last lesson we talked about something finding the slope of tangent line and also find the equation of tangent line, right? And we showed several examples. Today, in this book, we have like 3.1, like here, it's called check. When I put a check here means you got to do it by yourself to check if you understand or not, okay? And here, I just show you how to use the method we learned and to apply to this question, okay? I'm going to show you in two ways. One is the format of the definition, slope of the tangent line equals what? Limit x approach to a fx minus fa over x minus a, like this. All right? So this is the first definition of slope of tangent line, right? Okay, now be careful here. A is the 4 here right now. And the function is the square root x. So we will have limits. We apply this definition of slope of tangent line to this question now. So we go x approach to 4. Fx, just the square root of x minus fa, which a is 4, so f4. f4 just square root 4 over x, just leave it at the x minus a is 4, like this, right? We directly use the definition, right? Now, the things is that if you directly put 4 in, that's the problem. Because 4 is here, 4 minus 4 is 0. 4 is here, square root 4 minus square root 4 is 0. That's 0 over 0. That's not good. So what we're going to do is this. We can simplify this one. We can simplify this one, square root 4, change to 2. No problem with that, right? That's just simplify. But still cannot do it yet. So here you can see that we need to use a lot of strategies, skills with the basic math part. Here in previous chapter, we learned about find the limits. And here we're going to use that. We time by what? We time this one, square root of x plus 2. And if you time this one to the denominator, you need time this one to the numerator, like this, right? So if you do this one, what happens? We call this one as a conjugate, okay? Square root x plus 2 is conjugate of square root x minus 2. Remember, at this time, we try to get rid of the indeterminate 0 over 0 type of limit. We try to time both numerator and denominator by what? By the, we call it as a conjugate of this numerator there, okay? Sometimes you need time by conjugate of denominator, depends on the case, okay? Now, you may ask why you have to do that. Let me show you why, okay? So when you do this one, you can directly get what? Top part will be square root x squared minus 2 squared over the bottom one, just keep it x minus 4 and the square root of x plus 2, like this. Okay, why this one equals this? Let me show you how. Of course, don't forget, when you do the work, right, you always remember to put what? The limits there, okay? Don't forget that. X approach to 4, like this, okay? Let me show you how. You can use difference of the two squares, a minus b, a plus b equals a squared minus b squared. A squared just square root x squared. B squared just 2 squared. That's the one way. Of course, if you feel uncomfortable with that formula, you still can do this way. You can go by this one times this one. That would be square root x times square root x, just square root x squared. And this one times this one, we use FOIL, right? We mentioned that's just a 4 more lessons. So add by 2 square root x. And this one times this one, you have minus 2 root x. And this one times this one will be minus 4. Or 2 squared is 4, right? So this two cancel. That's why you have this one. Okay, when you got this format, things will be easier now here. So we can get what? Limit x approach to 4. This one will be x minus 4 over the bottom one. You have x minus 4 and the square root of x plus 2, like this. When you got this one, the things is easier because you cancel this 2. So you see here how effective if you time numerator and denominator by the conjugate of this numerator, you will cancel this zeros here. So x equals 4, approach to 4, just directly plug it in. So you have 1 over this one here, right? There's 1 here. So square root 4 plus 2 equals 1/4. Okay, we can find the slope, right? After we find slope, we can find the slope intercept form or point slope form of the line. How do you find tangent line? We can go like this here. We're going to point slope form one more time, okay? Y minus y1. y1 is root 4. Root 4 is 2. Equal slope is 1/4. And x minus what? 4, like this, right? Y minus y1 equals 1/4 slope and time by x minus x1. x1 is 4. So you can distribute it in and add by 2 on both sides. You will get a y equals to 1/4 x minus 1. So this one times this one, 1/4 times -4, so -1. And then you plus 2. Finally, you can get a y equals 1/4 x and plus 1. See, that's the one. We can get the slope of tangent line, right? And remember, we have the other format of the definition of the slope of tangent line. Remember that? Slope of a tangent line will be equal to what? Limit, right? Let me put it here. That's the time we learned about limit h approach to 0, f a plus h minus f a divided by h. This is another format. This is one format, this is another one. Both represent the slope of tangent line. We can use this format also get the slope of the tangent line at x equals 4. Be careful here, the a here is 4. So this one can change it to limits, right? H still approach to 4. H approach to 4. H approach to 0, sorry. H approach to 0. And F A is 4 plus H minus what? F4. Okay? Divided by H, like this, right? Now, what are we gonna do? I put the work here, okay? I put the work here. So we will have limits H approach to what? 0. F4 plus H means what? They have square root 4 plus H minus what? F4, right? F4 just square root 4 divided by h, like this. Now, be careful here. When we have this one, we need, of course, this square root 4, we can change it to easier. So we can put 2 here. So be careful here. We still use the strategy we learned, time both numerator and denominator by what? By the conjugate of this numerator. So I can time this one by square root 4 plus h. This is minus here. We put this one as a plus 2. Of course, you time something to the numerator, you have to time the same thing to the denominator, right? So you're going to have square root 4 plus h plus 2, like this. Now, when you get this one, you will have, this is the a minus b, a plus b. You can directly get what? Limits h approaches 0. A squared will be square root 4 plus h squared minus b squared is 2 squared. I'm directly using difference of the squares, right? Of course, you can still work with FOIL, okay? I showed you before. So the bottom one is h and the square root 4 plus h plus 2, like this. Now, what happens? This one squared, we're going to have what? 4 plus h minus 4 over h square root 4 plus h plus 2, okay? And the limits h approach 0. Don't forget that, okay? And then here you can see that this one, 4, this 4 cancel each other, no more. So you have this now. And then you can see that h and h cancel. We need to cancel the h because there's a 1 and 1 now. And then we make this h approach to 0. So you will get 1 over square root 4 plus 0 plus 2. And then square root 4 will be 2. 2 plus 2 is 4. So that's 1/4. Is here? Same as what we got here. Right? So you see how effective we're using is what? We're using 2 different definitions to apply it to the question practice of this 3.1 here. Find the slope of tangent line, and also we can find what? Equation of tangent line, we find it here. Okay, and next lesson, I'm going to explain to you about the derivative of the function at the point. At this time, I just will give you a preview on this one first. Is here? This one, do you notice that? This one is exactly the same as what? Slope of the tangent line. Slope of the tangent line. So, see from the beginning of the lesson of this chapter, what we're trying to do? We try to show you something with derivative of a tangent line first. Of course, we introduce it from what? The secant line first, and then tangent line slope. And then I'll tell you that this is the definition of the tangent line. We code it as what? Derivatives. And also we can code it as what? Differentiation. Okay, so this two is very closely related. So the whole calculus, AP calculus, basic part is what? From limits, we go to differentiation, and then we go to the integration. Okay, so this is the second part, of most important thing there. It's called derivatives. This one we will formally introduce the definition. And I would like to share with you something. When you read the math book, please pay special attention to the highlighted part. That's the one, is the key part of the theorem of the calculus here. All right. So, so this is I'm going to close for this video. And if you have any questions, please let me know. Okay. Thank you. Okay. Bye-bye.